we've been doing all of this work with data, different forms. How do you read it? How do you see what is available? Why do you do certain things? When's a good situation to do certain things? So today, we're going to kind of blend a couple of things from the last few days. We're still going to read data from a graph, a dot plot in this case, but we're also going to bring back into play a little bit with mean, median, and mode. So we can actually start to wrap up how these all go together. So, okay, a dot plot can take on some other forms, but sometimes it can be known as a line plot. Even though we're not making lines per se, they can look a little different. These could be connected instead of being dots. But most of the time, they're going to look this way. And so we're going to plot the data, hence plot, on a number line, either using dots or X's. So either basically tell me the same thing. So this first example, students timed how long it took them to eat their lunch. What? Eat their lunch? 1 minute? What the heck? Must be a competitive eater or something. So the dot plot represents the data. They're all eating way too fast. Way too fast. So just like we've had in the other ones, how many students took 8 or more minutes to eat their lunch? I'm going to kind of color code here. So we'd basically just be looking at that group. So 1, 2, 3, 4, 5, 6, 7. Okay, we're not looking for percentages or anything yet. We might get to that. Oh, hey, speaking of, what percentage of students ate their lunch in 5 minutes or less? Now here we need a little more info, because we don't just want the number strictly, we're looking for a percentage. So 5 minutes or less, there's my people that are 5 minutes or less. So we got 2 steps to this. 1, 2, 3, 4, 5, 6, 7. Okay. So 8 students did, but that's not the question. It says what percentage? So to do a percentage, I need to know the total number of students that were in my dot plot. Sometimes they'll be nice and give us a title and say how many, but this time not so much. So we said we got 8 here, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 19 students total. So now that I know how many total there are, how would I find the percentage? 8 over 19. So let's see here, 8 divided by 19. And just a reminder, okay, it wouldn't be 0.42. We'll go to the nearest whole. Whenever you're doing this, you can always just multiply by 100 if you wanted to see. If you wanted to be real specific, I guess you could say 42.1. But that's how those are going to work. So a good chunk of them are eaten really, really fast. And then we get to bring in some old stuff. What's the average time it takes this group of students to eat their lunch? Now, this gets a little more interesting and a little more time consuming if we're going to go ahead and do this. You're like, okay, so how could I go about doing this? Well, you've got a couple of options, and don't worry, this is not something I would do to you on a quiz necessarily. So you start to look, you're like, wait, so wouldn't I have to, let me bust this out. Do I really want to write all this out? I'm going to, if you just want to watch, you can. So what I'm going to do, and you could do it on the calculator to make it go quicker, but since I'm doing notes, now, some of you may find a faster way to do what I am doing. I know of a faster way, but I'm not going to say yet. I'm going to kind of go in the ridiculous mode here. This is going to work, but Basically, when we do average, we need to add up all the values and divide by the total number of data. If you wanted to do this a little bit faster, we could have just done like 1 plus, there's 2 2s, so we could have done 2 times 2 here. We could have done 3 times 4 there to make this a little quicker, but hey, sometimes slow and steady just is going to have to win the race. So now I just got to make sure.
Please, for the...
Sure. Yep, let me get that up here. We'll get that in there because nobody needs to see my crazy need. I am going to want to have somebody double check me though. I just came up with a better idea than what I could have done here, but we're going to see. Okay, I'm pretty sure I'm right. Come in from the side here. So I got 112 total at the top, divided by 19. Anybody have an idea, maybe based on what we did yesterday, that could possibly have been a faster way for me to get my average or my mean? Like, oh, what I could do if I pull out my calculator. Fortunately, my list was empty here. I think it's faster, but I don't know if some of you are going to agree with me. If I would have gone ahead and popped them in here, knowing this would tell me that I did the right number of students, and then I could just go ahead. Again, using my little cheat sheet. Always want to use the cheat sheets when we got them. And there's the 5.89 or 5.9. So if you don't want to go to all the writing that we did here, that is an option for you if we remind ourselves that average and mean are one and the same. So this next part, we're not going to sit and do a bunch of calculations, but I do want you to be able to kind of get these down as far as looks. So dot plot down here on the bottom, talking about pets a little bit, okay? So to create a dot plot, you can use dots or X's. We kind of need to know how many animals we've got here. So let's see. So we've got cats, that's 1. We got dogs, that's 2. Rabbits, fish, turtle, guinea pig. Okay, 1, 2, 3, 4, 5, 6 different animals. So we want to space out a little bit. Cat, dog, rabbit, fish, oh boy, turtle, guinea pig. Again, the order won't matter. Like, your dot plot can look a little bit different on your stats. If there were in numbers, like we had up above with the time, we would want to put those in numerical order to make sense. But when you just have random items like we do here with our pets, not as big of a deal. And so now all I've really got to do is go through and see. All right, let's see here. 1, 2, 3, 4 cats. You can do dots, you can do X's. Does not matter. I'm even going to change colors here. Dog, 2, 3, 4, 5. 5 of those. Right. Rabbit, only 1 rabbit fan. All right. 1 rabbit. I think I'm going to run out of colors. Fish, fish. Fish, fish. Turtle, turtle, turtle. and one guinea pig to wrap up, and we're going to have to repeat a color. Visually, for someone, this is going to be better because you can visually see, you know, if you're asked a question, which is most popular, which is least popular, which ones have the same amount of people. It's faster to look at that than have to go back and forth in a list. So the dot plot does have some benefit as far as that goes. But our main job more is going to be to read it than it is anything else with those. So, how do we use these? Kind of the way we went yesterday into mean, median, and mode. When do we want to use each one? So what we're going to do here is to start figuring out, how do I compare them? How do I know if I'm doing them correctly? And things like that. So the first part we're going to look at is a definition of something called the spread. And that is when I'm plotting my data, the difference between the greatest and the least value. In math, we call this the range, okay? Bottom to top, top to bottom. And it describes how far apart the data is. If you have data and it's really far apart, that may be just because there's a lot of differing opinions or statistics. It may be because someone's trying to fool you. It depends. That's why it's important we take a look at this. And so when we do these, that can affect the shape of our dot plot. Okay? If it basically is the same all the way through, and when I say that, I mean symmetric would say you'd have the most data in the middle, but if you look off to the edges, you see about the same amount of data on each side. It makes kind of what's called a bell curve, where it's smooth and consistent. But sometimes you're going to have what's called a skew, which means if I just kind of drew a line that kind of curved over the top here, whichever side that you start to see where it's going way down and then it's consistent, that's the side of skew we're looking at. So this might be a skew of, I don't know, let's see, homework scores in my Algebra 2 class from 0 to 5. Just a few 5s, lots of people not doing anything, okay? We don't want it to be that way, but that's what the data would tell us. Now, skewed left is what you want as an educator. Very few people on the low side, and everybody over here as we go. But again, where that little tail at the end comes, that's what determines the whole left versus right when it comes to a skew. So we need to pay attention to those things. So then when we get to the center, now we get back to what we were talking about yesterday. The center of the data is either the mean, when we do the average, or the median, which is when we put the numbers in order and we see which one's in the middle. So if it's skewed data, the median is going to be our best measure because it's going to find the middle and it's going to find that value, even if there's a weird number way out to the edge, an outlier. But if it's symmetric, okay, this is going to be best done by our mean. So I'm actually, just a second here. I'm just to kind of, I'm a visual person. And so to me, seeing the words that go best with the type right in there with the chart is going to make more sense to me when I go back and I look at it sometime to try and figure this out. And so with these, we're just going to go ahead and mark these. The explanation isn't going to be as huge as just kind of recognizing things. But what you do with any of these, if you're trying to figure out a skew or symmetric, is you're just kind of making a curve over it. And if you're never coming back down like a bell curve, it's not symmetric. Again, where's the narrow part? Where's my tail? Whatever direction that tail is going, which is left, is going to be my info. But if I get a nice curve and it goes up and it comes back down, that's going to be symmetric. Again, when you go into education, they tell you, hey, you kind of want to see the bell curve here. Everybody's doing pretty good. We got some people doing okay. We got some people not so much. We just don't want to see, a huge skew. Oh, especially not this way. We're tailing down to the right. Going that route. And so we can do a lot more with these than just figure out, hey, which way is it skewing. We can actually do domain and range and domain and range. Now I'm heading to my next hour. Mean, median, and mode when we're working with dot plots as well. So label each graph with its shape, which measure of center would best represent, then find it. Okay, so let's come up here. Now, some of the things we're not going to worry about as much. So a couple of the questions down here we're going to skip, but 2 is not one of them. So I look, and if I kind of just follow in the tops to make my curve, which one of our 3 types does that look like? Symmetric. So since this one's symmetric, would I use mean or median for this one? Mean. So we're going to find the mean. But unlike what we did before and typing in every single number, which again I could do, what I'm going to do instead is I'm going to kind of, let me get out of here. I could type those, well, let's play with both, and then you can kind of tell me which way we should do moving ahead. So I'm looking here, and I'm like, all right, so I got 6, and then I have 2 8s, so 8 times 2 is 16, and I got 4 9s, so I got 36, and I got 3 10s, so that's 30, and I have 1 11, I have 1 12. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 dots. And I get my answer. That's one route you can go. You can add them all. That works too. One more time on the reminder though. And again, you've got these, or at least you should, if somehow yours got misplaced. I have more. But you also could just come in here, go to the top and clear this, and then just type in 6, 8 twice, 9 4 times, 10 3 times, 11 once, and 12 once. 12 numbers, I can see it right there. But once I have it in, I could just go to Stat Calc, and there's my 9.25 as well. But I'd also, if I decided I was going to do median for one, I'd have that in here too. So I mean, I think there's good to all of our methods, but again, about this one?
Skewed right.
Skewed right. So whenever we're skewed, what's our better measure, mean or median? Median.
Why is it skewed right for
So mean is only going to be used when we're symmetric because that's going to be the most accurate if we're looking for an average of what's going on.
why you put mean for skewed right on the sheet part?
Oh, no.
Oh,
Well, that's all right. I was going to say, I've been known to do some kooky things. It happens. It does. I didn't this time, but it don't mean I won't be the next time, probably. So here, if I wanted to, now this is where this gets interesting. We've talked about how you can count in from the edges if you want to with these. That's a little trickier on a dot plot because basically what you're doing is you're going, all right, so mark those, mark those, mark those, mark those. And you end up here in the middle. And hey, it's 7 and 7. I think I can figure this out. It's 7. If the visual on that isn't quite what you would want it to be, we absolutely, there we go, 4 6s, 4 7s, 3 8s, and a 9. And I can let my calculator do it. And there again, there's my median. My median is 7. So you're always going to have those options to be able to look at those. So one last question on this one I want to do. We're going to skip over 3 and 4 for now because that's getting into modes and some other things like that that we don't necessarily need to get into at this point. Do you agree with a competitor's claim? Okay, let's read up here. A popular fruit snack company comes in 2 varieties, regular and less sugar. A competitor claims that the less sugar version is the same as the regular, just with less fruit snacks in the bag. Now, that'd be one way of doing it. The competitor randomly buys 12 bags of each variety and makes dot plots of their findings. So do you agree with the competitor's claim that the less sugar snacks are simply regular fruit snacks with fewer in the bag? Use the dot plots for your answer. So over here, we had about a little over 9 in every bag in the regular. In the less sugar, there was 7-ish. So does it seem like the competitor's right? They're just shorting you fruit snacks? Seems that way. Because the less sugar is skewed right, meaning there's less snacks overall, because most of those look like they were 6 or 7 snacks in a bag compared to 9. That's one way to say there's less sugar. That's some shady stuff. So, like I said, this is kind of cleaning up our statistical data with dots and pie graphs and bar graphs, histograms, and mean, median, mode. Tomorrow, we're going to kind of blend things together and kind of see how things are going as far as that goes. But for the moment, and Hardy is on the wrong page, hang on for just a moment here. I got to get to the right page myself. So we're going to work on some stuff with the dot plots over here. So we're going to be looking at page 15 and over to 16 where you actually get to see how the plots work. If we need to do some questions as far as dealing with these tomorrow, we absolutely can. We're going to have plenty of time to not only play with some of the homework and the practice that we've done so far, but also to work a bit on this preview, getting you ready for the quiz. So 15 and 16 is where you're at. Again, there's keys up on Classroom if you want to check something as you go. Otherwise, I can jump in and help out as well.